Okay, so today's lesson is going to be on median and mode. These are the other two ways of measuring central tendency. The first one, of course, was mean. We covered that last class. Let's get started. So today's plan, continuing with interpreting statistical data today by introducing two new measures of central tendency. This is going to be calculating the median of a data set, which is basically just the middle number. The median is the middle number. We'll talk about that in a bit, though. And then the other thing we're going to cover today is the mode. And the mode is just the number that appears the most often. Okay, let's get started. So talking about average, recall from last class that average, quote unquote, usually refers to arithmetic mean. And arithmetic mean we denoted with this X with a bar on the top of it, right? That symbol means arithmetic mean, or in other words, just the mean, right? Now the mean is found by adding all numbers in a data set together and then dividing by the number of numbers in the data set. So in other words, if you had, let's say, like 8 numbers in a data set, so 8 different things, and you're trying to find the mean of all 8 of those things, you would add them up and then divide by 8. You just divide by the number of numbers in the data set. Now, using the mean can have flaws, though. It's not always the best way to calculate an average, quote unquote. Remember, we usually mean, like by average, we usually are talking about the mean, but average can mean some other things as well, not just the mean. Anyway, let's calculate the mean income of these 4 people that I've put in here. We got Tom, Megan, Shirley, and Peter. To calculate the mean, you just have to add all of these up and then divide by the number of numbers in this data set. And there's, of course, 4 numbers in this data set. So to do that, let's just write these down. 35,000, that's what Tom makes in a year, plus 290,000. That's what Megan makes in a year, and then Shirley is making 33,000. And Peter is making $47,000. If you add all of that up, I've already done it here, I've got it written down. If you add all that up, it should give you 405,000. And of course, that's not the mean, that's just the total sum of all 4 of these people. So we just have to divide that by the number of people in this data set. So in other words, we've got to divide it by 4. 405,000 divided by 4 is 101,250. And of course, that's going to be in dollars because it's an annual income. So in other words, the mean income of these 4 people is $101,250. If you look at these 4 people, there's only one person who's like sort of, you know, making, I don't even want to say making close to that. They make way more than that. Megan is making a huge amount of money here, whereas Tom, Shirley, and Peter aren't making nearly as much. If we looked at this as being our mean, personally, I don't think it's a very good way of representing the average income of these 4 people. And the reason it doesn't do a very good way of estimating the average of these 4 people is because there's really only one person who's making way more than everyone else, like way, way more than everyone else, almost like 8 or 9 times more. And that's what's bringing this number up, right? If you look at Tom, Shirley, and Peter, this number, $101,250, that doesn't even come like close to what they're making in a year. It's way, way more than that. So I don't think this is a very good way of measuring an average. And really the reason that this is happening in this case, again, is because Megan here is making way more money than everyone else. In other words, Megan is what we would call an outlier. So an outlier is a number in a data set that is way off what the other ones are, and that's what's throwing us off. If we ignored her altogether here and we just found the mean average between Tom, Shirley, and Peter, we'd probably get a better indication of what the 3 of them are making on average. So again, this brings us into a conversation about the median. That last example showed how outliers, which are numbers that are much bigger or smaller than the rest, can skew the data, right? So Megan's number, of course, made that number way off what it was supposed to be. Like the mean average was way, way more than what it was supposed to be. So mean isn't a good measurement for those kinds of data sets. If you ever have some outliers, or even just one outlier, mean isn't usually a good way of finding the average of that data set, that measure of central tendency, as we call it. Instead, we can use something called the median. Now, the median is the middle number in a data set when listed in ascending order. So ascending order, of course, is from the smallest number to the biggest number, okay? So sometimes for data sets with an even number of numbers in the set, though, there's 2 middle numbers. When you have that situation, you can't have 2 different medians. You actually have to take the mean of those 2 numbers to find the median. So that was why we learned about mean before we learned about median, because sometimes, again, if you have an even number of numbers in your set, you actually have to find the mean of the 2 median numbers. It's kind of weird. We'll see an example of that in just a second though. Let's start with one where there's an odd number of numbers in the set, like this data set right here. Find the median of this data set. Now, something like a very common mistake that people make is they see their numbers and they go, oh, it's the middle number. I just got to circle the middle number and I'm done. But wait, you got to remember it has to be listed in ascending order. In other words, if you look at this list of numbers, it's right now not in a proper order. It's kind of just jumping all over the place. We have to take this number set and order them from least to greatest. Well, the smallest number in this data set is 12. So I'll write that down first and I'll cross it off as I go. Then the next smallest number is 14. And then we have 15. And then we have 17. And last we have 19. Now that these are organized in ascending order, in other words, from least to greatest, we can now find the median. And the median is the middle number in the whole data set. So if you look at this data set, the middle number is going to be 15. Okay, so the median of this data set is 15. That's the middle number. So coming back to that same example from before with Tom, Megan, Shirley, and Peter, let's now find the median annual income for these four people, right? Well, let's list these first of all from the lowest annual salary to the highest annual salary. So Tom, nope, sorry, not Tom, Shirley. Shirley is the one who's making the least here, 33,000. So we'll cross that off. Then the next least is Tom, 35,000. Then we have Peter at 47,000. And of course, Megan making bank here, 290,000. That is now listed in ascending order. But notice, because there were 4 different items in this data set, that we actually have 2 middle numbers, right? Because if there's a middle in between here, you'd say the middle somewhere right here, but we really have these 2 middle numbers. But unfortunately, we can't just say, oh, we have 2 medians. That'd be really nice if we were able to say that, but unfortunately we can't. So what you do from there is you have to find the mean of those 2 middle numbers. So the mean of these 2 middle numbers is going to be 35,000 plus 47,000, which gives us 82,000. But then, of course, we have to divide it by 2 because there's 2 numbers that we're adding together here. So now chop this into 2 pieces, and you're going to find that 82,000 divided by 2 is $41,000. Okay, so $41,000, that is the median of this data set right here. And if you think about median as being another way of finding average, I think you probably agree that if you looked at these numbers, 41,000 is a pretty good approximation for what the average person here makes. The old number we had before was 101,250, which like totally ignores Tom, Shirley, and Peter, who aren't making even remotely close to that much money. But 41,000 is probably a better measure of the average amount that these 4 people are making, right? Megan's a huge outlier here, right? So her numbers are going to skew the rest of this totally. But remember, that would be a better way of representing this because she's an outlier. Anyway, the third and final measure of central tendency that we're going to discuss is called the mode. The mode is simply the value or values that appear most often in a data set. I should underline that. There you go. Most often in the data set. So unlike mean and median, however, there can actually be more than one mode. That's totally acceptable. You don't just have to have one mode. There's not just one answer necessarily. There could be, but you can have 2 modes or 3 modes or 4 modes. You could even have no modes at all. Like you could have like literally not even a single one mode, right? So just keep that in mind. Now this is super useful for when you want to find the most popular choice. So of course the number that appears most often is going to be the most popular number that appeared in the data set. So of course the mode represents whatever is the most popular. So our elections, of course, that works sort of technically, I guess, based off of the mode, right? So if you gave each political party a number, and then instead of voting for a party, you would vote for that number, right? The number that would appear most often in the ballot box is the one that wins. So it really is the mode of that data set, the data set being all the ballots submitted in an election, right? Now, another thing, just to let you know, stem and leaf plots, which we learned about last class, that can actually be very helpful here as well, because a stem and leaf plot is a visual way of organizing data, and you can more clearly see in a visual way which numbers appear most often. So speaking of stem and leaf plot, here's one right now. It says calculate the mode of this data set. Notice they did their stem and leaf plot a little different than what I usually would do, in that notice for the stem of 5, they had no leaves. Oftentimes I just ignore that because that means there's nothing that's 50-something in this data set. And same with 9, right? So there's nothing that's 90 something in this data set, so you can just ignore that. Bottom line is what I'm getting at here is we're looking for the mode, so we're looking for the number that appears the most. If you scan through this, you're going to see that in the 60 column, or row I should say, sorry, the 60 row, where the stem is 6, 8 appears twice. So that means 68 actually appears twice in this data set. Might be useful to note. Now notice also in the 7 row, so the 70s, 2 appears twice. So in other words, 72 is a number that appears twice in this data set. Looking through the rest of this list, we don't have anything else that follows that same pattern. So the mode of this data set is actually 68 and 72. You can have 2 modes. That's totally acceptable. Do not find the mean of these two, like you don't find the middle point or anything. It's just that we have 2 winners here. The ones that appeared the most often here were 68 and 72. So in other words, that would be our mode. Now let's calculate the mean, median, and mode of the following heights of famous actors. Here we go. So we're going to summarize everything all in one big question. Just in case you're wondering, this data apparently is accurate. I looked it up on Google and I threw it together. So these heights, of course, for these 5 actors, that is actually apparently accurate. So we want to find the mean, median, and mode of these people. Let's start with the mean. Remember to calculate the mean, you have to add up all of the numbers and then divide by the numbers in the data set. So let me write that all out. Danny DeVito is only 58 inches tall, so we'll go 58 plus Keanu Reeves is 73 inches tall. Jim Carrey, 74 inches tall. Christian Bale, 71 inches tall. And Matt Damon, 70 inches tall. And if you add all of that together, let's see here. Oh, I actually didn't write that down. Here we go. It is, there we go. Now I got it. So 346 is the sum of those 5 numbers. 346, though, that isn't our mean average. That's just the sum of all of them. Now we have to take 346 and divide by the total number of numbers in the data sets. 346 divided by 5. That is going to give us 69.2 inches. So that would be the mean average height of these 5 people. Let's see how this compares now to the median and the mode. If we look for the median is the middle number if you listed these from least to greatest. Well, the shortest person here, no surprise, is Danny DeVito, so we'll write him down first, 58. Next shortest person here is Matt Damon, 70. Next shortest would be Christian Bale at 71. And then we have Keanu Reeves at 73 and Jim Carrey at 74. The median is the middle number in the data set when organized from least to greatest. That would be 71. So 71 inches is the median average. Notice how it's a little bit different than the mean. It's a different number, okay? Last but not least here, we've got to find the mode. Remember, the mode is the number that appears the most often in a data set. Kind of silly in this question because all of these numbers are unique. There's no number that appears more than once. You have some options here. You could say that all of these are the mode because they all appear the most common. But generally speaking, if everything only occurs once, I usually would just say that there is no mode in this case, right? There's no clear winner, quote unquote. There's not a popular number that appears here. If we had someone else here that was the same height as someone else, like for instance, Christian Bale. My height is also 71 inches tall. So I'm the same height as Christian Bale. If you threw me in here and said, oh yeah, Mr. Scott, 71 inches tall. Here we go, 71 inches tall. Boom, all of a sudden now we have a mode, right? But we don't have me in this table, so we're not going to include that. There's just no mode in this case. Now, the last question here I'm going to ask you is which type of measure of central tendency, so mean, median, or mode, would be best used in this situation? Well, I think you and I can both agree, before we even think anything further on this, clearly it's not going to be the mode. There is no mode here. You can't say mode is the best average of this if there's no mode, right? That doesn't make any sense. But between mean and median, it just comes down to perspective. Now, remember what I said earlier. Mean has a weakness if there's an outlier. In other words, if somebody is kind of throwing the data either too high or too low, that means mean is usually not the best way of doing this. Well, if you look at Danny DeVito here, he's only 58 inches tall. And in case you're wondering, by the way, 5 feet is 60 inches and 6 feet is 72 inches, right? So in other words, Danny DeVito is under 5 feet tall. He's 4'10", right? Everyone else here is pretty darn close to 6 feet tall or taller. Like Matt Damon, of course, is the next shortest person. He's still 70 inches tall. That's 5'10", right? He's not short by any means, right? So in other words, Danny DeVito is kind of throwing all of these numbers off. When we found our mean compared to our median, though, I'm quite impressed. In this question, the mean and the median aren't too far apart, only about 2 inches apart, right? But I think, personally, the best one to use in this situation would be the median. And the reason for this is because Danny DeVito is an outlier. In other words, he's much shorter than the rest. Okay? If it was someone else who was maybe 68 or 69 inches tall, so not super far off the rest of this data, then I would say the mean is probably the better way of doing this. But because Danny DeVito is throwing this number off by quite a bit, like he's considerably shorter than the rest, I would definitely say that median would be the better way of doing this. Anyway, for some practice, please complete in your work booklet, page 115 to 119, all questions. Just so you know, Friday, April 3rd, is going to be given to you as a work day. In other words, it's just going to be a day for you to catch your breath and complete all of these questions, as well as all the questions from the last day. During this work day, if you have any questions about any question in particular, please send me an email, okay? Let me know that you're stuck on a question and I can help you out. Anyway, best of luck. Talk to you soon.